There is a prerequisite which is required to prove that an irrational number is actually an irrational number. So there is a theorem, and this theorem states, let P be a prime number. And if P divides A square, where A is a positive integer, then P also divides A. Now let's look at the steps that will help us prove this theorem. Now what is being said? A square is divided by P. Now for your P to divide A square, A must have a factor P. From the FTA theorem, we can say that A is equal to X into P. So let's write that down. A is equal to X into P. And here X and P are prime factors. Got it? X and P are prime factors. Now let's look at an example. Let's prove that root 2 is irrational. Okay, let's prove that root 2 is irrational. Now, what is the first step? Step 1 is to assume that the statement given is false. So they asked us to prove that root 2 is irrational. Let's assume that root 2 is rational. Okay. Now, if root 2 is rational, shouldn't root 2 be written in the form of A by B, where A and B are co-primes and B is not equal to 0? That's right. So here, if a number is rational, then it should be written in A by B or B by U form, where the denominator is not equal to 0. So if root 2 is rational, then this should happen. We should be able to write root 2 in A by B form, where A and B are co-primes. Okay, co-primes means nothing but they have one factor in common other than 1. They have a factor in common other than 1. Now let's see. Okay, now let's square on both sides. If we're squaring on both sides, you have root 2 squared, which is equal to A by B whole squared. Now let's, this square and this root gets cancelled. So 2 is equal to A squared by B squared. Now after this step, if we cross multiply, let's cross multiply, then it will become, your B square will go up here. So it will be 2B square is equal to A square. Now this will tell us that 2 can divide A square, and that A square has 2 as its factor. So now from the prerequisite theorem that we already learnt earlier, we said that if A square is divided by a certain number, then A is also divided by that same number. So if 2 can divide A square, then 2 can also divide A. If 2 can divide A square, 2 can also divide A. So we can write the previous step as B square is equal to A square by 2. Now this will become your equation 1. Now like we already said from the previous theorem, if 2 divides A square, then it must also divide A. Now from FTA, we can state this. A can be written as 2C. So A can be written as 2C, where C is an integer. Okay. Now let's substitute this in equation 1. Let's substitute this in equation 1 because you have A here and you found the value of A. So what was your equation 1? B square is equal to A square by C. No, by 2. Okay. Now what was your equation 1? B square is equal to A square by 2, and A, we got A as 2C. So let's put this over here. You have B square is equal to 2C squared by 2. Now this can be further written as 2 into 2 into C square by 2. Let's cross one of them out and you get 2C squared. So B squared is equal to 2C squared. So let's write that down again. B square is equal to 2C square. Now let's send 2 over here. That makes it B square by 2 is equal to C square. This means that 2 also divides B, because if 2 is dividing B square, it should also divide B. So this leads us to this fact that A and B can be divided by 1 and 2. Co-prime should have only one common factor, but here you have 2 common factors. So this means that A and B are not co-primes. So what was our statement initially? Our statement initially was root 2 is rational, so root 2 can be written as a by b form, where a and b are co-primes. We just showed that a and b are not co-primes, which states that root 2 is not rational. What does that mean? It means that therefore root 2 is irrational. Now let's look at another example to understand this better.